Code Emotion.
My name is Arun Gupta, and I work for Oracle. And I'm here to talk about WebSockets and server-sent event. And my goal would be, in this quick 40 minutes, kind of give you a quick overview of what WebSocket and server-sent events are, how the two are different, and hopefully show some code examples as well on how we can actually build a standard-based application using both of these. Okay. So as I said, a quick WebSocket primer, then a code sample for it. Same thing, server-sent event primer and a code sample for it, and how the features for that are available in the Java platform. Now, HTTP by nature itself is half duplex in the sense that client makes a request to server, then server understands the request, then makes a response back. So at a given point of time, client can send to a server or server can send to a client. The protocol is well established in the sense it's request response. Or even if it's one way, then you send a request, still get a response back as HTTP 201. And it's very chatty protocol in the sense when you are sending a request from client to server, there are a chock full of headers that you need to send as part of the request. As a user, it's not visible to us, but essentially the browser or the client is sending a whole bunch of headers that goes as part of the request. Same thing as part of the response. The crux of the message really goes as the HTTP payload. And that's sort of what is useful to us. We don't care what headers are going over the wire. That's HTTP's problem, not ours. So what that makes it difficult is very challenging for using HTTP for any real-time communication because there's so much overhead of the protocol. So people worked around those problems using Comet, polling, long polling, with different programming models, with different APIs. And they have essentially all been hacks so far in terms of how they're going to look like. So that's exactly where WebSocket comes into the picture. It says, hey, you know what? We're going to provide a full duplex, two-way, bidirectional communication channel over a single TCP. Unlike HTTP, where every time you want to make a request, a new TCP is set up, a new HTTP is set up, and all that connection negotiation has to happen. With WebSocket, it's a single TCP connection. Your existing HTTP gets upgraded to WebSocket, and there are standard mechanisms defined for that. And then there onwards, on that single TCP connection, no tear down, the client and the server, they're full duplex in the sense client can send as many requests to server, and similarly, server can send as many requests, not really responses. Server can send as many requests to client. And these are essentially bidirectional in the sense client can send to server, server can send to client any point of time. Any design pattern, even request response, you have to build on top of that basic primitive of one-way request that is going from client to server or server to client. So that is sort of the basic premise of it. Now, when people talk about WebSocket, they're really talking about two things. First is the protocol, which is RFC 6445. So Google for it, you'll find it. It's an IETF standard. It defines exactly how the wiring or the framing of the protocol is going to look like. That means on the wire, how the protocol is going to look like. And then the second part that people talk about WebSocket is the JavaScript API, which is defined by W3C. Now, if you're using WebSockets from browser, of course, JavaScript is sort of the lingua franca over there. So in that case, you got to have a WebSocket API that is defined by W3C, and then the browsers need to support that API. So how does the whole thing look like in terms of connection establishment? Well, there's a client, there's a server. They are trying to connect using normal HTTP methods. So in that sense, client makes a HTTP request to the server. The first request, as you can see over here, is just a normal HTTP request. The important headers to recognize over here is upgrade and connection. Now, those are standard HTTP headers. HTTP defines the upgrade mechanism by which you can upgrade an HTTP connection to a newer version of HTTP. They happen to be using this for WebSocket. So it's the standard HTTP header saying upgrade the connection and upgrade to WebSocket. And then there are a bunch of other headers as well for security, origin check, and things like that. We won't get into the details. But those are the two important headers. So you're making a HTTP GET request using HTTP 1.1, and that is the URI that you are making a request to. Now, this is over the TCP connection with HTTP. If the server does understand it's a WebSocket endpoint, which is /chat effectively, then you're saying the server will respond back, oh, you know what? I'm going to upgrade the connection. I'm going to upgrade it to WebSocket. Again, those are very standard headers defined by the HTTP specification. And then it's saying, oh, I am switching the protocol from HTTP to WebSocket. Then onwards is no longer HTTP. It's a single TCP connection. Same TCP connection is now WebSocket. Anything that you send on it is your application specific. And the beauty of WebSocket really is it's a very lean protocol. I mean, I'm a runner, so I enjoy the being lean part of it, and that's what makes it more efficient. So it can go in a long run. In the sense, the amount of framing required, unlike HTTP, where you have to do a lot of framing in terms of headers and body and payload, etc. Here, the framing is pretty minimal, literally 2 bytes of overhead. Everything else is the payload. So let's see. Now, a client makes a HTTP request saying, I want to go to a handshake request. Then you get a handshake response back. At that point of time, the client and server are really connected. The important part to realize is once the client and server are connected, they're purely client and server from the perspective of who's receiving the request and who's initiating the request. But once they're connected, that's it. Actually, there are some seats up here in case you guys want to come over here. So once the client and server are connected, they're actually all pairs. So now the peers can communicate with each other. They both have equal capabilities. They can send a message at any point of time. They can initiate the termination, all of that. So how does this work? Then, well, there are callback handlers defined on both the sides. On the peer 1, let's say the client peer and the server peer. Once they both call open, the client peer sends a message, 1 message, 2 message, 3 message. Notice the server is not responding back. There is no request response design pattern. Your application has to build that design pattern on top of this basic primitive. The server may say, oh, you know what? I got received 3 messages. That's my design pattern. Now I'm going to send a so-called response or a message back to my client. It may say, you know what? I received data from client and I didn't like it, so there's an error here, either parsing the error or communication error. And there are callback handlers defined for that. Then more messages. Eventually, the client peer says, oh, you know what? I'm going to terminate the connection. The server peer could have easily initiated that termination as well. At that point of time, the connection is terminated. Okay? So that's sort of the basic message flow that happens between the client and the server and eventually peers. Now, this is a quick overview of what the W3C API looks like. It is still a W3C candidate recommendation. Now, that's one of the W3C technical jargons. That means it's not a standard yet, but it's sort of still the de facto standard, used pretty heavily already. In here, for example, you can say, I'm going to define a WebSocket. That is the URL where my WebSocket endpoint is going to connect to. There are certain state elements over here. These are my callback handlers. For example, we were talking about on open, on error, on close. WebSocket has this concept of extensions and sub-protocol that allow the WebSocket protocol to be extended. For example, you can use multiplexing or compression. Those are sort of some of the common extensions. But extensions by itself is a pretty niche topic at this point of time. Now, these are the methods by which you can actually send data from client to server. I mean, remember, this is a JavaScript API, so it's primarily used in the browser environment. So think about the client perspective. So this is where you're using your send messages. There are 4 send messages, and JavaScript has a binary data type. So you could send blob or array buffer, which is a native binary type for JavaScript. You can send that data as part of this API. So you can say send either text data or the bunch of binary types over here. So WebSocket can handle both text and binary data. How many of you use Internet Explorer as your primary browser? Okay, excellent. That's what I love to see. Nobody. And don't be ashamed if you're using it. Well, the reason I ask that is, up until recently, IE had no WebSocket support. And IE 10, they have just added support literally like late last year. And I have not tried it myself. So I've only heard rumors that they have WebSocket support. But otherwise, other than IE, all modern browsers, excluding IE, have support for WebSocket. And that's what I meant by saying that the WebSocket support needs to be part of the browser itself. It's not a JavaScript that you can put as part of your application. Oh, I understand WebSocket. I'm going to write my WebSocket.js, bundle it my application. No. Because there's a JavaScript part is one part of it. The protocol is the important part of it. How on the wire message exchange is going to happen, how those callback handlers is going to be invoked. So that all that concept is got to be baked into your browser. So you can go to this website, caniuse.com/websockets, and that website will give you an idea of where your favorite browser is. Pretty much all the modern browsers, and I fail to understand why the native Android browser does not support WebSocket again. But otherwise, all the modern browsers now support WebSocket. So I was wondering, what is it that WebSocket is such a big deal about? So yeah, I understand, there are a few bunch of headers going back and forth between REST, which don't go as part of WebSocket. So I did some internal benchmarking for myself. And so what I did is I wrote a REST endpoint, just an echo endpoint, and similarly a WebSocket endpoint. And then these are like my HTML5 progress bars. So I send messages and I receive messages, just a plain echo, okay? Nothing fancy over there. Then I said, okay, I'm going to send 10 messages of 1 byte, just a byte. And same thing I'm going to do for WebSocket as well. And then I'm going to start comparing the numbers. So if you look at it, 10 messages of 1 byte REST endpoint, just a pure REST endpoint, just get, okay, is 200. Well, this is not a get. This is a post, actually, because you're actually sending data and getting back as well. So this is 220 milliseconds. This is about 7 milliseconds. Okay? Now that's 10 messages, comparable, barely noticeable. Let's increase the payload. So 100 messages, 10 bytes. So we're bumping up by 10x over here. About a second, and this is still 57 milliseconds, way down there. Let's bump up the load again. Again, 10x. So 100,000 messages and 100 bytes. So this is about 10 seconds, and this is still about 200 milliseconds, way down under 1 second. This is where the significant difference is. We're sending like 5K messages of 1,000 byte each, 1 kilobyte each. This is about like 55 seconds, and here is about 1.2 seconds. So that's where the importance of WebSocket is for real-time communication, because the framing is so lean. It is a much better protocol for real-time communication. You can send quick spurts of data, like if you want to send a JSON, you're not sending like a 50K of JSON. That's not a good design programming. So if you're sending like 1 kilobyte of JSON, which is a very typical payload, think about it. If you're sending 5K messages, it is pretty scalable that way. Now, something else that I'm going to do beyond this is one client sending multiple data to the same endpoint. What I want to take a look at is how about if I say, simulate like 100 clients. How does that work out? How does that kind of take into consideration? But this is at least a basic data point for us. This is a baseline, and then we can work upon that. So let's take a look at how we are building that support in the Java platform. Now, JSR 356, that's how we build specifications in the Java land. JSR 356 is a specific number where we are adding support for doing WebSocket-driven development. And in that, we are defining annotations. For example, on any POJO, you can put a @server endpoint annotation, and that will become a WebSocket endpoint. We'll take a look at that. Not just annotation-driven, we have an interface-driven approach as well. So you can say, implements this interface, and it gives you a little bit more tighter control over what kind of messages and how you want to deal with the life cycle and all those things as well. Okay? We, of course, have a client endpoint as well. Now, remember, W3C defines a JavaScript API, but there is no corresponding client aspect of it. And that's exactly what the JSR 356 is going to define. So let's take a look at quick samples, and then I'll show you something live as well. So very canonical hello world. How does it look? Well, hello bean, string, say hello, take this parameter, return string, Pojo, right? Nothing fancy over there. How do I convert this to a WebSocket endpoint? Just add server endpoint. Single class, one annotation, boom, that's it. No deployment descriptors, no other fancy annotations required, just one annotation. Well, this is a WebSocket endpoint. Message is being received. Which business method you want to call? You put @onMessage on that. Okay, so that means this is the method that you want to invoke whenever the WebSocket endpoint is being invoked. The payload is automatically mapped to my very first parameter over here, which in this case comes out to name. In this case, I am specifically designing a request response design pattern in the sense, oh, this is my request and this is my response going as a return. I could very well make it as void as well, in which case this is just receiving requests. I'm just sucking up the request from the client. I may respond back whenever I want to, in which case I go with the, there are other design patterns in the WebSocket API which would let you say, oh, for example, here I could say comma session. That gives me the client which is actually making the request. So let's say I can say, I'm going to receive 5 requests. Then to the session, I'll say send the request back or send the message back. The bunch of annotations here. This is what turns the Pojo into a WebSocket endpoint. This is when Pojo wants to act as a client endpoint. Again, I'm talking the terminology client endpoint. We have regular callback handlers here on message, and we can have the variable URI path parameters as well. Now, as I said, WebSocket sends text data and binary data. That is good, but excuse me. If you're receiving JSON data every time, it's going to be tricky, because that means you're receiving the JSON data, then you somehow have to convert it into Pojo and then act upon it. You don't want to act upon maybe JSON raw data as is. Or if you're getting a binary data, you may want to receive it as a Java AWT image or something like that, or some of your own binary data, binary format, or your own Pojo. So that's exactly the concept of encoders and decoders. WebSocket API defines how you can define encoding from text and binary to your Pojo, and vice versa, from your Pojos to text/binary. You can define, the idea is to follow the dry pattern here. Don't repeat yourself. You define those encoders and decoders once, and then you specify them as part of the annotation. How does it work? So for example, I have, I just use the same class here because it's eventually implementing interfaces, but I could have my message encoder, my message decoder. I have 2 separate classes where I'm doing the encoding and decoding, and I can specify them on my Pojo, and that'll just work out of the box. Okay? And I'll show samples for this. How does my encoder and decoder look like? Well, in this case, all I'm doing is I say my message implements decoder.text. Yeah, this is messy. It should be decoder.text and encoder.text. This is implementing both decoder and encoder as well. So these 2 methods, decode and will decode, comes from decoder basically. It's saying, oh, I'm looking at my string data. Can I decode this message? So then you return true. And if you return true, then that particular decoder gets picked up. And then eventually in decode, you're decoding it. And here, what I'm using is standard JSON API. That's yet another feature we have added in the Java EE 7 platform, standard JSON processing API. So I'm saying, JSON, give me a reader. This is a DOM reader. From the string reader, give me the string, which is what the inbound payload is. Grab the payload, read the object, and give me JSON object here. Similarly, in encode, I take my message, which is basically my JSON object, and then I say, convert it into a string. So Pojo to string, string to Pojo. This is my string or text-based encoding decoding. I could do the same for binary as well. And in that case, the messages, the interfaces are different. So decoder.binary, encoder.binary, and instead of string, I'm taking and returning byte arrays. Okay, I'm going to show you a quick sample. So let me show you the sample first, then I'll try to explain through it. So this is a collaborative whiteboard that I built using simple HTML5 canvas. I can pick the color, shape, and then I can say, OK, I'm in an online mode, so keep transferring the data as I'm doing it on my whiteboard here. Okay? So you'll see the changes here. So I say, OK, red square. As I'm clicking it, now make it a blue square, change the circle, or color as well, and play around with it. Everything gets transferred to me as is. Now I'm saying, you know what, I'm not in online mode anymore. I'm going offline, and I'm going to do some processing of the data. So let's say add some more values here. Oh, sorry, back here. I'm going to add some more data here, no more transfer. Now let's say a new player joins the game. Or let's think about this as a game, for example. Now let's say a new player joins in. So I'm going to go here. A new player is joining in. Okay, so actually here. And then I'm going to say, OK, how do I make sure that the data is being transmitted to the new player? So I say, send the snapshot. So when I click on snapshot, so you'll see this is Chrome, this is Firefox, and this is Safari, 3 different browsers. These could be on 3 separate machines altogether, perfectly fine. So now the data is all replicated in all 3 browsers. Now the key part that I want to highlight through this demo is when I'm clicking on the browser over here, okay, what's really happening is I'm clicking here, is grabbing the JSON coordinates, is sending the JSON coordinates to all the listening endpoint or the listening clients for me. The client gets the JSON coordinate, refreshes itself. That's it. It says, OK, hey, in the JSON, I'm saying, what are my, well, I'm sending JSON structure. In the JSON structure, I'm sending the X and Y coordinate, and I'm saying what shape and what color. Based upon that, I just draw on my local client. Now, when I'm saying send a snapshot, then I'm doing a binary data transfer. I'm saying capturing the binary data and say send the data. Let's take a look at the code now. Now, this is my simple WebSocket.js that I have created, and it's pretty straightforward. I'm saying, OK, connect to the WebSocket endpoint. WebSocket, instead of HTTP, connects with ws://. That's the protocol that you need to use. You start with that protocol, the upgrade automatically happens for you. You don't need to do anything. I just explained that concept that is done by the underlying container for you. So he's saying, OK, connect to this endpoint, which is where my endpoint is listening. I'm creating a new WebSocket. And if I'm doing the binary data transfer, it's going to be array buffer type. And then I'm defining my handlers. So whenever message is received, call this on message. Or whenever error is received, call this message. Okay? And then I have my simple text and send binary. Just kind of put different console.logs. And here I'm saying WebSocket.send JSON and send bytes. Okay? So that's that. In terms of my WebSocket endpoint, that's again pretty simple. I have add server endpoint. I'm saying this is the URI where my endpoint is being listening. These are my encoders and decoders. So if we take a look at the encoder, for example, it's saying encoder.text. So it's basically returning a figure element for me. It's taking a figure. Now remember, it's encoding. So it's encoding a figure to a string. Takes a figure, returns a string. And then I can go back to my figure decoder, for example. Now the decoder is taking a string and converting it into a figure. So here I'm saying, OK, take a string, create a JSON object, return it back as a figure. Okay. Excuse me. Something else that maybe we can take a look at is, well, this is all application code here. If we take a look at the figure class, figure.java is pretty straightforward. All I have is a JSON object over here, just getters and setters over there. And coordinates, again, very simple, just float x and float y. Now, one thing that you may want to look at is here. Now, this is what I'm showing you is a Google developer tools. This is sort of the JSON structure that is being received. Now, remember, I was clicking in the Safari browser. The data was being received for me in the Chromes. So here in the Chrome, I'm saying, for example, in the JSON structure, I'm getting shape, square, color is whatever this R, red, color square, and these are the coordinates. These are the coordinates that are being received by my browsers, all my listening browsers, which then just draw the whatever shape in the right coordinates. Something else that might be useful for you is like WebSockets. The traffic can be observed natively in Chrome developer tools. For example, well, let's take a look at it quickly. So here, for example, I can go to network. I can say, show me the WebSockets. Well, I need to refresh the page, so it won't show it otherwise. But what you have is the data here. It kind of shows you a snapshot. So well, this is Wireshark actually. And Wireshark is what used to be ethereal, and this is like a network sniffer. So it's going to show you the entire stream of packets, literally on the wire message. You can take it as is, and it's going to show you the entire stream, how it's looking like. So you can follow a TCP stream or a HTTP stream. It's showing you what the messages are, and what the more details are. This, on the other hand, is a snapshot from Chrome. For example, you can see how the live WebSocket packets or frames, which is the WebSocket terminology, can be tracked. Okay? And I'll share the slides, guys. So by all means, I'm all for sharing. Switching gears, server sent event. So WebSocket, WebSocket is sort of the pampered child, so to say. Although server sent event is older. But WebSocket is, because of the two-way nature, of being so efficient, has always gotten more love. Server sent event, on the other hand, is part of HTML5 specification, but is primarily, well, it is only server push. In the sense, if you don't care about two-way communication, all you want is the data from server pushing, like a stock ticker or something like that, or you're a passive Facebook reader. I just want to get a feed. I don't care about posting anything. So you can do things like that. Same thing, there's a JavaScript API. On the client side, you are listening using event source API, and then you can define your message callbacks. And I'll do a comparison between WebSocket and server sent event as well. Similar API, this is again defined by W3C. So for example, you can say, I'm going to create what is the event source URL that I'm listening to. So somebody on the server is basically pushing out events that you're listening to. You got some states here. You got your regular callback handlers, and there is no sending from this side because that part is handled by WebSockets. So let's take a look at server sent events example. Now, how does that look like? So in this case, I'm saying, this is the URL that I'm listening to. Now remember, this is on the client side, so there's no cross-site scripting that is possible here. So you have to say just web resources, items, events. I'm just listening to a REST endpoint, which is going to publish a bunch of events to me that I'm listening. So here I'm saying, this is the event source. This is a standard JavaScript API, and pretty much supported across the board by all the browsers. So you can say, this is the URL I'm listening, and this is the event source API. Then in here, I'm saying on message, which is my standard callback handler. I'm going to listen the message. Whatever event comes out, I'm just going to log it. Log.data, very standard one. Okay. And here, slightly different from server WebSocket is you can have your custom message handlers. For example, in WebSocket, you can only have, for example, on message. That's it. That is the only event handler that you have. Here, I'm defining my custom event listener, say size. So for example, somebody from the server is spitting out data as size, as that is the event that they're spitting out, then you can listen for size. So you can do a little bit more sophisticated programming in this case. Now that's the client side. On the server side, how does it look like? Well, on the server side, of course, we have to have, by the way, this slide that I'm talking about here is Jersey specific. Now, Jersey is a reference implementation of JAX-RS, or Java API for RESTful Web Service. And the reason is only in Jersey and not in JAX-RS at this point of time is because HTML5 will hopefully be a specification in 2014. We cannot include non-final specifications in a final JSR. So that's the reason this feature is incorporated in Jersey. Hopefully when HTML5 goes final, server sentiment goes final with that, we'll incorporate that as a standard in standard JAX-RS as well. Until then, we have this feature and support available in Jersey. So what we're doing is we're saying, oh, this is a server sent event broadcaster. I'm going to create a broadcaster, and I'm going to spit out a bunch of events. And in this case, all I'm doing is think of this as a REST endpoint. In the REST endpoint, I'm saying this is the path where I'm listening for all the events, and I'm going to produce a whole bunch of server sent events. Again, remember this. This is Jersey specific. I'm quoting that again. And here I'm saying is, okay, I'm gonna to the broadcaster, I'm gonna send the event. So this is what the broadcaster is gonna spit out. So you're saying, okay, event output is the kind of event that I'm gonna spit out. Now you have subscribed to the URL, and broadcaster is what you're listening at. So then what you say is, let's say you have a method in your REST endpoint, and I'll show a live sample of this as well, where you say, okay, add fruit or add an item. Okay. So now let's say I'm submitting it using a HTML form. So once you say add fruit using add form param, you can just grab the value from the HTML form. You get the value in here. Then you can say, oh, fruits.add fruit. That fruits may be my database, whatever it is. I'm just adding it to my REST business logic. Now this is where my server sent event comes in. In the server sent event here, I'm saying is, oh, broadcast a new event. And in this case, I'm saying, okay, use the builder API. This is a type of the type string, and this is the value that I want to broadcast. That means fruit is the actual fruit that is being added. I'm broadcasting that as an event. Now remember, somebody else may be updating maybe calling your REST endpoint, and somebody else may be listening to your events. In this case, it happens to be the same, so don't get confused in that sense. Somebody else may be pumping your data, and somebody else may be listening to the data over there. Think of a stock ticker example. So this is one event where I'm pumping out data, which is where my on message on the client side is going to get called. And here is where I'm spitting out a specific data, a specific event by the name size. So I'm listening to it on the client side. So let's see a sample of this. So all I'm going to do is I'm going to add some elements here. So if I add AA, just a random name here, I mean, it's not a fruit really, but but you add a fruit here. Let's add a fruit actually. Well, never mind, too late. So if you're adding AA, for example, here, that's how I've been using my test data. That's what comes to my mind. So when you add AA, so this is, remember, this is my custom message that I'm receiving on the client side with the size. And this is my standard on message that I was talking about. So now let's add a real fruit. Apple. And here, again, I receive the custom message and the standard message. So all of that is possible. So let's, okay. Let's kind of compare and contrast, your server sent event and WebSockets, which is sort of the last part of the presentation anyway. So let's take a look. WebSocket, as I said, is over a custom protocol in the sense, from HTTP you upgrade to WebSocket, yes, but then it's a new protocol altogether. It's no longer HTTP. Here, it's over simple HTTP. You're just using HTTP, and it works out of the box. And I'm not listing them in order of pros and cons. I'm just kind of comparing and contrasting at this point of time. WebSocket is full duplex. That means server to client, client to server, and bidirectional. That means both the directions it works. Here is server push only. The issue with that is when you are doing, if you want to do client to server, that is out of band. You may use XML HTTP request, but that's completely out of band. Your application defines that protocol, and then there is overhead of creating TCP, HTTP, all that crap. WebSocket, as I said, native support in most browsers, in modern browsers at least. But here, for example, if you want server-sent event, you can actually polyfill it. You can create your own server-sent event.js and put it as part of the browser, and that will work. That's not the case with WebSocket because it's a protocol level thing right there itself. It's very simple protocol. So for server push, if that is your only requirement, bingo, you don't need to go anywhere else. It's not straightforward protocols. If you take a look at RFC 6445, you'll realize it's kind of complex, but that complexity is hidden in day-to-day use for you by the browsers. As I said, in WebSocket, we have predefined message handlers. Here you can define your custom message handlers. We took a look at an example of a size, for example. In terms of WebSocket, what is the application specific? Oh, design patterns. So you design your application patterns, request response, or whatever that pub, sub, all those protocols you define on top of WebSocket. Here, there is built-in support for, sorry, too bad, different topic actually. So here, there is built-in support for reconnection and event ID. In the sense, if a server-sent event connection is established and that times out, it automatically reconnects after 30 seconds, and that's configurable. Here, if the connection is lost, it's lost. You have to start brand new HTTP, and then you have to build all of that logic as part of an application. Now, as I said, this is a custom protocol. So proxy servers, caching servers, DNS servers are still catching up. They may need some configuration. This is over HTTP, so it just works out of the box. Here, binary and text both is supported. There is no support for binary types here. Last but not the least, all the resources for you. So Java API for WebSocket. This is JSR 356, part of Java EE 7, integrated in Glassfish. Same thing with server-sent event. Not part of Java EE 7, but integrated in Glassfish. Excuse me. Questions? I'm sorry, this is a very fast-paced session for that early in the morning.
So WebSockets is not integrated in Jersey, it's not part of Jersey?
It's a separate specification, separate the question is WebSocket not integrated in Jersey? So WebSocket is not part of Jersey by design because WebSocket is a separate specification and implementation, but they work very well with each other. WebSocket, from your perspective, what you're looking at is Glassfish. Glassfish is the delivery vehicle for Java EE 7. WebSocket, Jersey, server-sent event, they're all integrated in Glassfish for you. What's not integrated in Java EE 7 is server-sent event. As I said, because server-sent event is not a final specification yet.
Two questions actually. What kind of server were you using for the demo?
I'm using Glassfish 4 build 78, which is about 2 weeks old. Build 80 is available, so that should just work.
So it's already available?
Absolutely.
Okay, and the other one was, were you using on the demo different browsers because you were using the session or cookies in a way that you couldn't connect with the same browser? You know, the figure.
Right. The question was why was I using different browsers? I just wanted to show the highlight that these 3 browsers, they support WebSocket. One part of it. Second part of it is.
Was it possible in your demo to use the same browser
Oh, yeah.
with different windows?
Yeah, different tabs. Yeah.
What about security?
A good question. What about security? So in WebSocket, you can do ws:// that is your standard text-based protocol. If you want to be a secure protocol, then you can say WSS, which is just like HTTPS. So you have a secure pipeline, and then you push data on that. I've been shown a signal. That's end of the talk. If you have any more questions, I'm going to be out in the hallway. Thank you.
Code Emotion.